Welcome to another thrilling episode of AI Frontiers, where the latest breakthroughs in artificial intelligence research are brought directly to your ears. Today, a deep dive into the fascinating world of natural language processing awaits, with an analysis of 47 cutting-edge research papers published on May 12, 2025, sourced from the arXiv preprint server. These papers fall under the category of computer science, computation and language, a field central to how machines learn to understand and generate human language. This episode is crafted for researchers, developers, and anyone intrigued by technology's role in shaping communication. Join in to uncover groundbreaking ideas, explore complex concepts made accessible, and look ahead to the future possibilities of language technology. Let's embark on this journey of AI-driven communication innovation together. Let's begin with an overview of the field known as computation and language, often referred to as natural language processing or computational linguistics. This discipline focuses on enabling machines to interact with human language in meaningful ways. Think of the technology powering voice assistants like Siri or Alexa, or translation apps that bridge language barriers during travel. These are prime examples of this field's impact, transforming communication in areas such as education, healthcare, and customer service. The significance lies in language being humanity's core tool for sharing ideas and emotions. When machines master language, they evolve from mere tools into valuable partners. The 47 papers under review today highlight advancements in reasoning, ethics, and accessibility, showcasing the transformative potential of this AI domain for global use. Turning to the first major theme from this collection, attention is drawn to enhancing reasoning and problem-solving in language models. A significant focus of current research is on improving how these models handle complex tasks, such as solving mathematical equations or writing code. Several studies explore optimizing training data to elevate performance in programming challenges. Others investigate how models can refine their reasoning by learning from peer interactions, much like students collaborating to solve problems in a group setting. The ultimate goal is to make AI more adept at logical, step-by-step thinking, a capability crucial for applications in software development and educational tools. This theme underscores a push towards smarter, more analytical language technologies. The second prominent theme centers on ethics and safety in language models, reflecting growing concerns about their societal impact. As these models gain power, issues like biases, fabricated information, often termed hallucinations, and harmful content come to the forefront. Research in this area includes testing models on moral dilemmas, with one notable study by Jiashan and colleagues examining performance in medical ethics scenarios. The aim is to ensure that models align with human values and minimize errors in their outputs. This focus is vital for building trust in AI applications, especially in sensitive domains. It represents a maturing field that seeks to balance technological power with responsibility. A third key theme emerging from these papers is efficiency and model compression, addressing the immense computational demands of large language models. As models grow in size, the need for streamlined operations becomes critical. Innovative techniques are being developed to reduce text processing by over 90% while preserving meaning, as demonstrated in a study by Forrester and team. The concept of tokenization, breaking text into manageable chunks for processing, is being optimized to cut costs and energy use. Such advancements enable AI deployment on smaller devices and in resource-limited environments. This theme is essential for scaling language technology to broader, more sustainable applications. Now, let's highlight some game-changing insights from across these 47 studies. One striking finding is that simpler designs can outperform complex systems in coding tasks, as shown by Zhang and colleagues with a solve rate exceeding 50%. Another insight, from Jiashan and team, reveals that while models structure ethical arguments well, they often lack historical and contextual nuance. Dynamic retrieval methods are also proving effective, enhancing answer quality by adaptively fetching relevant data. Advances in temporal reasoning show models predicting the relevance of facts over time, a potential boon for fact-checking. Lastly, small alignment tweaks have boosted performance by 7% in certain tests, demonstrating the impact of precise adjustments in language technology. Delving into the methodologies behind these innovations, several core techniques stand out. Reinforcement learning, where models improve through trial and error rewards, is widely used to refine reasoning and align with human preferences. Retrieval-augmented generation integrates external data to ground responses, reducing errors in technical fields. Data augmentation creates synthetic scenarios to train models on diverse cases, while fine-tuning tailors them to specific niches like medical texts. Additionally, new benchmarks and metrics are developed to evaluate performance beyond basic accuracy. Each method offers unique strengths but comes with trade-offs in computational cost or precision, shaping the landscape of language research. Focusing on a seminal paper by Zhang and colleagues, titled, "Putting It All into Context, the Power of Simplicity in AI Agents" is explored. Selected for challenging the trend of increasing complexity, this study achieved a remarkable 50.8% solve rate on the SWE bench coding benchmark using long context language models. By feeding the entire task environment into a single, powerful model, it outperformed intricate multi-component systems. This finding impacts developers by reducing setup time and resource demands, suggesting a shift toward optimizing input design over adding layers. It highlights the potential of streamlined approaches in making advanced AI more accessible. Another influential paper, by Jiashan and team, titled, "Are Large Language Models Complicated Ethical Dilemma Analyzers?" addresses AI's role in moral reasoning. Chosen for its critical insights, this study tested models on 196 ethical scenarios, finding they surpass non-experts in logical structure but falter in contextual depth and historical understanding. This reveals a gap requiring human oversight in sensitive decision-making. The work influences policy on AI use in high-stakes areas like healthcare, emphasizing the need to balance logic with cultural nuance. It serves as a cautionary note on the limits of relying solely on models for ethical guidance. The third standout paper, by Forrester and colleagues, introduces Hypernym Mercury, a technique for token optimization. Selected for its groundbreaking approach to efficiency, it slashes token use by over 90% while preserving text meaning, tested on diverse works like Dracula, by Bram Stoker. This compression lowers computational costs and energy needs, enhancing accessibility for AI deployment in resource-scarce settings. Its versatility across texts marks it as a pioneer in semantic compression, potentially transforming how language data is processed at scale. This innovation could inspire a wave of research into efficient AI solutions. Looking to the future of language technology, several promising directions emerge from these studies. Hybrid systems combining human oversight with AI capabilities could address gaps in ethical reasoning and contextual understanding. Standard benchmarks are needed to ensure fair progress tracking across research efforts. Expanding multilingual and multimodal models will promote global inclusivity, while efficiency innovations must preserve meaning as models scale. Security against adversarial attacks and solutions for data scarcity through synthetic datasets are also critical. The path ahead holds immense potential, tempered by challenges that will test the creativity of researchers and developers. Let's explore a key technical concept: retrieval-augmented generation, often abbreviated as RAG. This approach enables models to pull real-world data during tasks, grounding responses in verifiable information to reduce errors. Widely applied in studies targeting accuracy in fields like science and healthcare, it helps cut down on AI hallucinations, those instances of fabricated facts. The relevance of RAG lies in enhancing trustworthiness of outputs. However, challenges remain in balancing the speed and cost of data retrieval with the quality of information fetched, a trade-off central to ongoing research in language models. Another vital concept is reinforcement learning, a method where models are trained through trial and error feedback. By earning rewards for correct actions, models gradually improve decision-making, mimicking aspects of human learning. This technique is frequently applied in the reviewed papers for tasks like reasoning and aligning outputs with human preferences. Its relevance is clear in enhancing AI adaptability, yet issues arise when reward systems are poorly designed, potentially leading models to adopt unintended behaviors. This remains a key area of refinement in language technology development. A brief note on how this presentation was crafted is in order. The content synthesis for this episode was supported by AI tools, specifically GPT Grok, Model Grok 3, to organize and summarize the research. Text-to-speech synthesis was handled through Google's technology to create the audio narration for these slides. Visual elements were generated using Stable Diffusion for an engaging experience. Human experts reviewed the material, though minor oversights may persist. All references are provided for transparency, encouraging further exploration of the original papers on the arXiv preprint server. As this episode of AI Frontiers draws to a close, an invitation is extended to join the community for more insights into cutting-edge research. Subscribe to AI Frontiers to stay updated on the latest breakthroughs in language technology and beyond. The channel, AI Frontiers, is dedicated to unpacking AI innovations for all, offering expert analysis on complex topics. Dive into the forefront of artificial intelligence with each episode. In this podcast, we bring you the latest breakthroughs in computer science and AI, straight from the arXiv preprint server. From neural networks to quantum computing, we simplify complex research so you can stay ahead. Whether you're a developer, researcher, or tech enthusiast, AI Frontiers keeps you informed daily. Thanks for listening. If you enjoyed this episode, subscribe for daily updates. See you tomorrow with more cutting-edge AI insights. Disclaimer. This video uses content from the arXiv preprint server under its API terms of use. AI Frontiers is not affiliated with or endorsed by the arXiv preprint server.